Okay, can you see my screen right now?
Yes.
All right. Okay. So good day, everyone. So today I'm going to present our research entitled Patch-Based Image Stitching for UAV Images with Natural Scene Distortions. My name is Markfield B. Pacot, and with me is my advisor, Dr. Nelson Marcos, for this research paper. So this is the outline of my presentation. I'm going to talk about first the overview of our work, followed by the objective of the study, the proposed solutions, experimental results, and the conclusions. So for the background, remote sensing is the science of acquiring information about objects or areas without physical interactions. It is done using notable technologies like UAV or unmanned aerial vehicle, which has an onboard sensors to capture this type of data. So UAV and remote sensing generally can be categorized either a passive type of remote sensing or an active type of remote sensing. So with that, these unmanned aerial vehicles in remote sensing has gained prominence in the different areas, also in known applications like surveying and mapping, environmental monitoring, disaster assessment and management, and many others. Also, another important benefits of having UAV and remote sensing is that it can cover wide range land areas compared to traditional Earth survey, such as the multi-type rotor of UAV or fixed wing type of UAV. However, during data acquisition, this technology is prone to distortion because of its unpredictable flight behavior. So common distortions include spatial occlusion, scene disorientation, similar interference, illumination change, which could affect which could affect the quality of the image. So in our research, we generally focus on what we call as natural scene distortion, which is one of an example of a geometric type of distortion, which is as depicted in this image, the region captured by the UAV will suffer different variation of angles of distortion, which is generally caused by the sudden pitch, roll, U movement of UAV, mainly influenced by UAV's altitude and speed, displacement of the surface elevation model, change of observed projection, which generally affects the appearance of the ground scene objects as depicted in this diagram. So, okay, next slide. Oh, right. So here are the sample UAV images that we acquired from the field programs operational planning division, Department of Agriculture, Manila, which we called it having a natural scene distortion, which generally has a characteristic of an extreme scene disorientation. So here we include image stitching, which is a known technique commonly used by the previously mentioned application from the previous slide. So what is this image stitching? It is basically a process of combining multiple images wherein you wanted to stitch it together or blend together to create a panoramic view or a mosaic, which can capture a broader field of view than what a single image can provide. So here is the image stitching framework, which generally used among many researchers. So we have here a pair of images. And then after that, we move it into the next phase, which is feature matching, which generally you can use traditional feature detectors and descriptors like SIF and others, or BRIS. Also, you can have a deep learning based type. So generally, you are going to get key points which represents the distinctive regions of these paired images. Then after that, you're going to move to the next phase, which is the image registration, which basically warping the source image onto the target image to blend together in order to form this image mosaic. However, when we performed experimental analysis on this existing framework, we found out this result wherein it has errors or deviations from actual position of objects and features where images contains the natural scene distortion or basically a scene disorientation on the 2D plane. We also tested other softwares in the field of geodesy like AutoStitch and PTGOE which suffered similar results. So the objective of this study is to develop a method for eliminating visual distortion when stitching UAV images with natural scene distortion employing a patch-based image stitching approach. So what is this approach? We have here a block diagram of our patch-based image stitching process, which generally composed of three key phases. We have the input phase, which we require or acquire the list of images containing undistorted and distorted images, but having the correct sequence. And then the process, which we have the two key components, wherein we have our natural scene distortion detection and patch-based image stitching, which I'm going to tackle later. And then our output phase, which we generally produce a UAV mosaic image mitigating the visual distortion. Also, we perform analysis on our model performance, basically our distortion and detection models, and the subjective and objective visual quality evaluation. So for our natural scene distortion detection and classification, this is having a 3K phases. So generally, our phase one is the list of sequential images of UAV having distorted or undistorted. And then we pass it onto our pre-trained network, which we leverage the old machine learning technique, which is transfer learning, which we coupled by our custom CNN with specific data like a 7 convolutional layer, 7 pooling layer, 3 fully connected layer, and 1 classification layer, which basically identify distorted and undistorted images. And then for the third phase of this one is the data aggregation, which is after identifying those distorted and undistorted images, it will be grouped together to produce generated subgroups. So basically that subgroups contain images of same class type. So for example, class 1, distorted images all, and class 2, undistorted images. We are going to determine later what is the effect on this data aggregation. For our second component, we have our patch-based image stitching, which after generating those subgroups, we will perform a first round patch-based image stitching, which basically stitching the images on that subgroups to generate sub-image mosaic. And then after generating this sub-image mosaic on those subgroups, we are going to perform again a second round patch-based image stitching in order to produce our final result, which we will try to eliminate visual distortion in the final generated mosaic. And then to evaluate the quality of the mosaic generated, we use the peak or perceptual image quality evaluator, which we have a table, which if ever the quality score 0 to 20, then it has an excellent result, and 81 to 100, then it has a bad result. We also use the background proportion matrix in order to assess the background proportion or the hollowness in an image mosaic. So using the simple formula like the area of background over the area of foreground. So for our experimental result, we wanted to showcase the performance of the CNN models together with the mosaic generation of images containing natural scene distortion. So first is our test data set. We have a site location in Candaba, Pampanga, Philippines. Wherein we have 4 flight plans. For flight number 1, we selected 36 number of data. Now we identify this number of images because our comparison to the existing softwares like AutoStitch and PTGOE, it will consume too much time when we are going to try more more images. So for our site 1, we have 36. For our flight 2, 108. And down to flight 4, 108 images. So here are the example of flight 1 screenshot of our data set. And then if we are going to zoom in some of the images, it has scene or natural scene distortion. For flight 2 dataset, it has, again, a scene disorientation. Same with flight 3 and flight number 4. Okay. So for the performance analysis of our models, we use transfer learning. And on our model 1, we use ResNet 18 architecture. And for our model 2, we use VGG16. So these models will basically perform the distortions, detections, and classification. So this is important because this is crucial in terms of generating those subgroups which could minimize the visual distortion in the final image mosaic. So our basis to choose the good model is that it can produce this higher number of subdirectories or subgroups and a higher number of accuracy in terms of classification. So we choose on flight 1, we choose model 2 with VGG16 architecture. And then on flight 2, we choose model 1 because it has higher number of subdirectories and higher number of accuracy in terms of classification. Same with flight 3 and flight 4. So for mosaic generation, so this is the result when we compared it to AutoStitch and PTGOE. So our solution, based on subjective visual evaluation, we can see that it produced somehow a quite or relevant or comprehensive visual presentation compared to the other softwares. Same with flight 2 data. We have this result. For flight 3 data, our solution also has a somehow a comprehensive representation of the image mosaic. And then for flight 4. So to evaluate the quality of the generated mosaic, on peak evaluation, we clearly somehow perform well because it generally does not got the top score, but it performed well because it is fall under the category of good image. However, when we tested using the background proportion evaluation matrix, our solution got the top score, which has got the lowest values. It's because it does not contain hollowness in the final generated image mosaic. So the conclusion, in this work, we present a patch-based image stitching approach that elevate the visual degradation in UAV-based image mosaic when dealing with perspective scene distortion or natural scene distortion. So our proposed solution outperforms well-known softwares like AutoStitch and PTGOE. Well, I'm going to clarify it in terms of mosaic generation and the pre-trained VGGNet, ResNet, and our custom models able to perform detection and classification, which is crucial in generation of those subgroups. And then our plan is to further enhance this model to improve the accuracy in terms of classification and detection. And then we wanted to improve our image stitching algorithm because we did not include the image color blending as visible in the final image mosaic. A picture is worth 1,000 words, but a well-stitched UAV mosaic is worth 1,000,000 data points. Thank you very much for your attention.
Thank you very much, Mr. Mario. We still have 5 minutes time. Is there any question from the audience?
I got question, Ibu.
Yeah, yes, please, Pak Arifin. Mr. Arifin will ask you a question.
Thank you, Madam Moderator. It is very interesting, the presentation of Mr. Pakot. I just would like to know in the model that he's doing some kind of analysis, to what extent the the knowledge about the dynamics of the UAV being incorporated into the analysis to test the team have some concern regarding, say, for example, the the Euler angle, if you like, the Euler angle Euler angle performance, roll, pitch, and yaw, something like that. How, in what way this kind of dynamics being taken care of in the algorithm being used.
Yeah, yeah.
Thank you, Ibu.
All right, thank you very much for that very comprehensive question. So I did not presented also the that's a very good question because the algorithm will determine I think the angle or the variation of the angles in our distortion that we are tackling with. So we have formulated using we created a simple using trigonometric formula to perform angles, and then in our study, in our experiment, the 5 degrees of negative 5-degree angle together with a positive 10 degrees or lower and higher, we can consider that our algorithm can determine that it has a extreme scene disorientation in the 2D plane. Now, higher than that or lower than that is our algorithm can still perform the type of distortion, particularly in the angle of distortion in the 2D plane. But in most extreme cases, the algorithm failed. No, I did not include. It's still on work on progress especially in identifying the exact limitation. But for now, we found out that negative 5-degree and the positive 10-degree, which we can compute using the homography matrix, we can observe that the algorithm can perform the general image stitching of those distorted images. Did I answer your question?
Yes, it would be clear. Thank you very much, Mr. Paku.
Yes, thank you.
Okay. Still another 1.5 minutes, probably another one question still possible. Okay, if there is no other question, thank you very much, Mr. Packard.
Thank you.
Yeah, okay. Now we can go to the second presentation for this afternoon. Mustafa Muhammad Kurdi.
Hello, everybody.
Okay. Hi. Are you going to present your paper, or you want us to play your video? Do we have video for that?
As you like. Okay, I will present my paper.
Okay,
Let's share the screen.
please. Okay. You have 20 minutes, include the question and answer session. Please start.
Yeah. Hello, everybody. We're talking about mathematical vibration model for attached camera system for a mobile robot. I am Kurdi and my colleague Ali Ibrahim and Alex Lubati from Belarusian National Technical University in Minsk. First, let's talk about why we have vibration or oscillation. During the navigation of the mobile robot, it traverses to find a free path from its origin to destination while avoiding obstacles. The choosing path should be optimal, which means to ensure that the robot uses the least amount of energy and time while moving from the starting to destination. While developing and installation of the mounted component on the mobile robot, for example, like camera or any other devices, facing several challenges, including occurrence of vibration. This is the main issue of our paper, referred to oscillation while traversing the air. The presence of vibration can result in adverse effect on the equipment that has been placed, particularly on our video system. Let us show, for example, a small like video about the navigation of the mobile robot named Belarusian 123N model. Sorry. It has the three types of this like robot: fully autonomous, semi-autonomous by using a joystick, as we can see, like this, and manual robot, which is like the low like micro quality, for example. And here, like we see, like the camera, the video camera from the mobile robot while traversing. This is unfixed. While traversing this robot, the video camera will be like oscillation or vibration. This is the main issue. Okay, let's continue. The problem, as you can see, the vertical component of vibrations and the corresponding camera attached on mobile robots. Like this is the main scene while vibrated, then like oscillated in vertical upward and down. What formal methodology may be employed to characterize and analyze this oscillation? It is the main issue. Is it possible to analyze frequency, amplitude, and facial patterns of vibration in video system in order to propose techniques for reducing their intensity? We mean by the random process. While navigating the mobile robot, position and navigation, the robot has like three major problems while navigating. Driving from initial point to the destination point from A to B, using a specific algorithm to obtain optical free path, and the last issue, or the last major problem, optimizing the robot trajectory. While doing this, the vibration will occur. Vibration for the mobile machine initiate oscillation frequency, causing them to emit disturbance frequency that closely align with their respective oscillation frequencies. The movement that occurs as a result is referred to as irregular rolling, characterized by an oscillation pattern characterized by an unpredictable amplitude and time. We use the exponential cosine correlation function as for the stationary random process xt, named by this formula. While dx is a process expression, alpha it is attenuation factor, and w0 represents the resonance frequency. In order to eliminate or to figure this vibration, we use a shaping filter. As we know, the shaping filter means a signal shaping filter, the filter that used to change the properties of signals in certain way, for example, for amplitude. Shaping filter can be constructed in a concept of random vibration process for a car robot, which is our robot, to minimize or shape the input vibration in a way that acceptable for the robot's control system. This is like this some examples of the popular shaping filter known as low pass filter, high pass filter, band pass filter, notch filter, and adaptive one. For a shaping filter, mainly the differential equations are used, especially for this for this our robot car-like robot, where m is the system mass, c is its damping coefficient, and x is stiffness, and x is the displacement, this the path or the distance where the mobile robot moves. The formula is used to tackle the problem of producing mathematical expression for the filtering of a stationary random process S of t is as yw, where s xw is the input signal spectrum density, while y is the output signals, and w phi is the system's amplitude frequency characteristics. So what's mean by shaping filter? And like going to our result or simulated experiment result, when a process vibration x of t are greater than a certain value, which is allowable value c, we are defined as a particular element, then the negative effect becomes apparent. We use this formula about emission intensity of mechanism given by lambda x of t. Like this is like a figure of our simulations, illustration of a vibration mechanism in an action, like starting from 0 and ending from 0. The maximum will be like 0.1 and the minimum is like 0.1, like like a homogeneous figure for our vibration, while this figure presents the change of probabilistic moments which we are solved, and the resulting graph of standard deviation of oscillation amplitude starting about from 0.03 at point 0 and goes up to about 0.8 at region TC about 0.5 and start and continue at a straight line. While the third figure shows our changing emission intensity, starting from about 0.5 at point 0, going down to about 0.2 at 0, about really يعني near to about 0, and then starting up to go to saturation or a straight line about at 0.7. The figure that depicts the graph of changes intensity of emissions of random vibration process in transient operating mode, which is our mode. As a conclusion, as you can see, the mathematical methodology which would we use the random process to assess the effect of vibration on mobile robot system is being developed and implemented using like MATLAB. Probabilistic vibration model and emission intensity properties are determined when using the delta lambda. The performance range and the probabilistic characteristics of reliable operation of elements of navigation attachment of told on the mobile robot, we mean by a video system, can be determined using an approximate mathematical model, which means a process model, for assessing the influence of vibration in these. Thank you. Any questions? We are ready.
Thank you very much, Mr. Mustafa.
Thank you. Thank you.
Okay. Are there any questions from the audience? You can raise your hand or you can ask directly. Is there any question? Mr. Mustafa,
Yes.
on your work, on your research, do you on your, or probably on your simulation, do you add if there are any obstacles around your equipment during the test? What gonna happen if there are obstacles like a stone, for example, or there are any other obstacles?
No,
What's gonna happen?
Thank you. Thank you for your question.
It's kind of silly question, but it can happen.
Okay. Mainly not in the obstacle in the like an instrument, like mainly the main obstacles was the navigation system we use for our robot. We really we address many algorithms for navigation system, starting from neural networks for like complex systems using, for example, a star, something like this. The main issue was using was our obstacles mainly the ground or the surrounding area. While using a flat region, like climbing like the mountain, like using traversing the mobile robot in heavy tree system, small tree, something like this. This is was the main issues, like or the main obstacles in mainly in allocating the video system and the vibration and how what to determine or to measure. I mean, really, this is the aspects or the problems or issue to handle. Mainly the area where this mobile robot will traverse. Mainly this is our concerns or problems.
So you haven't taken into account during your experiment those kind of obstacles.
Yeah, really, we use really at this moment we use like simulation system. Really, when
Okay.
we are in the next step, we are going to make it a real one and measure this fairly really in the real simulation, not a simulated one, a real majority, real world, especially like for navigations, especially in agriculture field.
Mhm. Yeah.
Okay.
Well, I raised that question since you have a filter on your system. That probably one of the tool that you can use if there is something happen or some obstacles. Then there will be a filter that can adapt your system to the new one or to the improved one probably.
No, not this. We use filter system just for make like a structuring or make attenuations or updating our signals, especially for this vibration. Maybe
Okay.
maybe there is another method or something like this. We don't use it. Just like for make like a modulate something like modulation as needed.
Okay. I see.
Okay.
Thank you.
Can I add
Pak
something?
Arifin, yeah,
Yes.
please,
Yes.
Pak
Thank
Arifin.
you. Thank
Thank
you.
you.
Mustafa, I just
Yeah.
would like, since the title of your presentations is about mathematical model. So
Yeah.
please show me two formulas that you have just given. First is about the stationarity of the process, and secondly, the differential equation. Please, could you show? Could you show again?
Show this equations. Yeah. Wait.
Yeah, regarding
Let
the
me share. Yeah. Just a minute.
the correlation functions.
Yeah. Wait. Correlation function.
Yes.
Okay.
Yes. Yes, that one. So
Yeah.
it is too small for me to read. Can you put into a bigger figure?
Yeah. Wait. Let's go to the main one. Just a minute. Make the whole figures.
You maximum presentation.
Put on slideshow, please.
Yeah, slideshow.
On the slideshow, so we can see it clearly. More bigger fonts.
Yeah.
Can we?
Yeah. Just a minute.
Yeah.
Do
So
you
in
mean
this?
this?
Yeah.
Yeah.
That very formula. So I'm just
Yeah.
wondering what random variables you are talking about here that you are presenting the Rx store. What the random variables?
Yeah. The Rx of T is our regular rolling process. Yes,
Rolling.
regular rolling process. Yeah.
Rolling means the angle. The
No,
angle of
rolling one like in the navigation like of the wheel, like regular rolling. While the
oh,
robot navigate the wheels go sometime, there will be a navigation. There is navigation, and when the robot traverse by using a regular rolling, not stable. We are not talking about a flat or stable ground. This is like unstable ground. While the robot navigates or traverse, there is a regular rolling. Means that the video camera will go up and down. It depends. Maybe like a small attenuation or small vibration, but the image will be something like this, like isolated. Depends on the area while the robot traversing.
Oh, okay. So it looks like that you are talking about the um, the radiant velocity, right?
Yeah,
Radiant, something
yeah,
like that. Okay.
yeah.
Okay. And you assume that this is going to be stationary.
That's true.
Okay. Okay. Uh,
Okay.
now, show me the what you call it, differential equations, the second order differential equations.
Wait.
Yes, that one.
Yeah.
So, is this X is the one that we are talking about?
Yeah.
Oh, okay. Okay. Okay, now it's clear.
Okay. Any questions?
Okay.
Thank you, sir.
Thank you very much.
Thank you.
Thank you, Parvin. We still
Thank
have
you.
2 minutes time. Another one question probably. Okay, if there is no question, then we can finish your presentation.
Okay.
Thank you very much.
Thank
You're
you.
welcome.
Have a nice day. Bye-bye.
You too.
you
We
very
go to yeah, applause from Mr. Agustin. We go to the third presentation. The paper titled Analysis of Unmanned Aerial Vehicle or UAV accuracy using post-processing kinematic or PPK method for measuring the situation of open pit mining. It will be presented by Mr. Sigit Kurniawan. Mr. Sigit Kurniawan, are you in the room? Oh, yeah.
Okay, thank you.
Yes,
Yes,
you
good.
can. You will have 20 minutes. Yeah, you can start now. Oh, yeah. Please, Pak Sigit.
Okay, good afternoon, everyone. My name is Sigit Kurniawan from Geomatic Engineering Department, Institute Teknologi 10 November. I would like to present about my journal, Analysis of the Unmanned Aerial Vehicle Accuracy using post-processing kinematic method for measuring the situation of open pit mining in PT Berlakol. We know that characteristic of coal mining industry are high cost, high technology, and mostly high risk. For safety issue, currently in my company for measuring the pit situation using terrestrial equipment. That's mean personnel approaching the measurement object. And for operational issue, it takes a lot of time and energy to move terrestrial equipment. But with technology development, we hope by applying the photogrammetric concept, topographic measurement for open areas can be carried out using UAV technology. Before, weekly topographic updated using terrestrial survey equipment like terrestrial laser scanner, GNSS, and total station. But in critical area cannot be measured due to limitation of the access for a surveyor for safety reason. But with drone technology can be utilized to reach out this critical area where surveyor cannot. There are many products that drone can be supplied, such as imagery and point cloud. The most accurate drone surveying means using ground control point. But number and distribution of GCPs depend on the area. That means larger area needs more GCP. The good distribution of GCPs sometimes located on high risk area, like on high wall or under critical slope in open pit mining. That's area potential for landslide. Therefore, the implementation of the GCP are greatly challenging for large area. So establishing ground control is expensive, slow, and may be not safe. But no, with PPK, the drone will geotag XYZ coordinate to each image based on that onboard GPS unit. Some research claim that PPK method can decrease the number of GCP to only one GCP or even replace it. That means no GCP anymore. Therefore, this project is designed to field test and implement it, the PPK method to establish the standard of the parameter to produce accurate data from indirect surveying. The objective of this study, analysis of the quality of the position of the mining situation from measurement using UAV. And then analysis of the quality of volume measurement resulting from measurement using UAV. And the last, it is hoped that measurement using UAV can be applied to measuring the situation of open pit mining and making them more effective, efficient, and safe. The study located in site Kurimbang mine operation in PT Brokol. The study area is 200 hectares. For weekly situation updated, before we are using TLS. We are using terrestrial laser scanner. That means surveyor needs more than one measurement station. Therefore, moving around the station needs to do. For the example, to cover 200 hectares, we need more than 20 stations. But now we are using UAV with PPK method. Surveyor just need one station to do takeoff and landing the UAV. That means no moving needs. We are using Wing Cawan Gen 2 UAV with 48 megapixel camera for data acquisition. The UAV flies at an altitude of 200 meters, and the front lap and side lap is 75%. And the PPK method consists of a GPS receiver which reference to the course. There were 679 scan of aerial photos. And the aerial photos were processed using PPK, and for geotagging, we are using the WintraHub processing. And this figure, we can see GCP and ICP. The GCP measurement are used to enhance the accuracy of aerial photo maps during the georeferencing process. And the determination of GCP location is based on real-time kinematic GPS coordinate. In this study, we use two GCP point. We also conduct for measuring totaling 12 ICP, refers to the SNA from big. We use as reference values compared to the positional information generated by aerial photos. In the photo, we can see GCP measurement, GCP and ECP measurement. The observation of both GCP and ICP are carried out in accordance with the order for observation specification at course by big within 1 hour's observation period. This is the result we can see at the table in 2 weeks period in 1st July and 7th July. We can see here the correction of the aerial photo position using the PPK and to GCP, similar error values compared to correction using only in the PPK method. And for absolute accuracy assessment is used to evaluate the accuracy of digital surface model and orthomosaic from aerial photo. We can see the RMSE and CA90 and LA90. The accuracy test result of the aerial photo which conducted indicated that our aerial photos meet the map accuracy standard of scale 1/1000 for both horizontal and vertical accuracy, falling into classes 1. We can see here for classes 1. And for the relative accuracy assessment is conducted to measure the volume difference from 2 DSM that are produced between using UAV and TLS measurement. The calculated deviation in volume between UAV and TLS was found to be 0.38%. That's mean consistent with ASTM standard, where deviation tolerance is 2%. So the conclusion are the absolute accuracy of the map and PPK correction modeling for 2 methods with GCP and without GCP in mining areas of PT Brokol were tested. Our results were matched with the SNI standard for Badan Information Geospatial for CA90 and LA90 format with a scale of 1/1000 class 1. And then the volume measurement result between UAV and TLS were compared with a standard deviation of 0.38%. This deviation meets the ESTM standard, which is 2%. And then measurement using UAV can be applied to measuring the situation of open pit mining and making them more effective, efficient, and safe. Okay, this is my reference. Thank you. Any question?
Thank you, Pak Sigit. We still have 8 minutes and half for question and answer session. Please, if there are any questions from the audiences. Yeah, Ibu Sasvina.
Okay, thank you. I have two questions. The first is, why are measurement using UFE more efficient and safe? And the second is, why use KCP can improve the accuracy? Thank you.
Did you catch the question, Pak Sigit?
Okay, thank you. Excuse
Yeah.
me. Okay. We can see here that UFE can measurement more effective, efficient, and more than safe. Yeah. We can see here for terrestrial laser scanner manpower, we need minimum 3 person, but with UAV we only need 1 or 2 person. And for station in this study we need 20 station, 20 moving equipment, but with UAV we only need 1 station and no need moving. And the risk for TLS high risk because the position of station may be on high risk area like on high wall and under critical slope. We can see here for total time in the acquisition data for TLS, we need 8.3 hours, but with UAV, the total time only 2 hours and 10 minutes. And safety issue for personnel must approach the area of the observation object for using TLS, but with UAV, personnel do need to approach the observation object area. Okay. And the second question, Mbak, lupa.
Mbak
Oh,
Sasvina.
The second question is, why using KCP can improve the accuracy?
Okay, thank you. GCP or ground control point is a control point used reference in mapping. This point has known an accurate coordinate, so it can be used as a reference to determine the position and size of the object being mapped. GCP can be used to increase the accuracy of mapping result, and then GCP can have correct data obtained from drone or UAV, resulting in more accurate mapping result. And then GCP is placed at a strategic area on the object to be mapping, and then measured using an accurate coordinate measuring by GPS. So by using GPS, position and size errors caused by GPS inaccuracies on UAV can be corrected so that mapping results are more accurate. Thank you.
Okay, Ms. Sasvina, is the answer all your questions?
Yeah, it's enough. Thank you.
Okay, you're welcome. Any other question from the audience? Pak Agusan, probably.
Cukup, mantap. I'm sorry. It's enough.
Okay. Okay. Let's see. We still have 3 minutes time actually. But if we don't have any other question, thank you very much for your presentation, Mr. Sigit. Okay,
Okay, thank you.
you're welcome. Now we can go to the next presenter. Let me check. The next paper titled Road Damage Dataset Evaluation using YOLO V8 for road inspection system. This paper is written by Mr. Agus Mulyanto. Mr. Agus Mulyanto is here. Is there? Okay, well, we were waiting for the presenter to be present in the breaking room. We can go to the next one. Paper titled Volume Calculation Accuracy for 3D Visualization of Flexible Pavement Damage Based on Low-Cost LiDAR. Miss Yusronia Eka Putri.
Yes, ma'am.
Okay. Now, are you ready to present your paper now?
Wait, 1 minute, please.
Okay.
Mhm. Okay.
Okay, now you can start your presentation. You have 20 minutes. Please start.
Yes, thank you. I think I'm the last but not least. My name is Yusronia Eka Putri. I'm with my supervisor, Mr. Priyo Suprobo and Mr. Trijoko Wahyu Adi. I'm from Civil Engineering Department, ITS. I want to present our research about volume calculation accuracy and 3D visualization of flexible pavement damage based on low-cost LiDAR. First one is about background. It is in this research about current condition, about assessment existing road in Indonesia, generally high cost, complex process, and also need extensive staff training to operate, and also extensive handling of data after processing. So, and also the high cost about data collection analysis of pavement profile data. It is for maintenance and rehabilitation decision is often made based on outdated data. The second one about LiDAR. This technology is high quality in producing precise and detailed data outcome. And this accuracy gain more faster data acquisition and processing. Most processes are automatic. The acquisition can be done day and night. About data density is very high and also useful for hard to reach area. The last is we use a low-cost LiDAR. It is introducing a novel opportunities for low-cost measuring equipment. In previous research, they have iPad Pro to use to make 3D buildings and measure the diameter of tree. So it is expected to be the low-cost LiDAR expected to be provide easy of implementation during field survey and post-processing. The goal of this research is about we make a test and compare performance of low-cost LiDAR, especially in 3D visualization and damage volume calculation. Yeah, and the goal of this study is to make use of accessible and inexpensive technology to improve the accuracy of budgeting, especially in infrastructure budgeting model for maintenance. This is hardware and software. First one is low-cost GNSS. This is can find coordinate of the longitude and latitude, and can reduce the cost of data collection in survey. The second one we use the LiDAR smartphone that can handle personal laser scanning with ultrawide camera and LiDAR function to measure object distance. This is reliable for portable, cost efficient, easy to move, fast, and also easy to use for 3D scan. Also, we use open source software like Cloud Compare and Global Mapper for countering, transfers profile, lengthwise, and volume calculation. So the scope of this research is device test about performance in 2 Apple LiDAR location in Kota Surabaya. The scan generates a short range and can application record video. We use 2 methods of data collection. First one is spot scan based sample scanning, and continuous scan based sample scanning. Bisa post data handling utilize of a few open source software. The methodology from this research is first one about data retrieval method, the measuring about the GCP with a low-cost GNSS receiver, and scanning using low-cost LiDAR device. This is can produce 3D raw data used to retrieve the position data, while it will later be used for georeference. About data analysis method, first one we get a georeferencing process, take some coordinate of control point, local coordinate, and make it transform to the global coordinate. The second one is 3D object analysis by utilizing georeference 3D modeling data, and some of the analysis in another part of my research is further implemented using the YOLO method for classification based on road damage criteria. The volume calculation, this is calculate the volume and area of road damage. This is a table for result about volume accuracy. Is divided into 2 categories. First one is spot scan and continuous scan pothole. With compare with measure about reference benchmark of volume with manual calculation for the volume of road damage pothole. This deviation is divided into two kind of Apple LiDAR, is iPhone and iPad. This is a with the spot scan scanning. We can get a deviation about 1.25%, and with a continuous scanning, we get an average deviation about 11.82%. This is a review about 3D profile, longitudinal profile, and transverse profile. The result is show that consistent representation of surface scan that can get a global coordinate that can be captured realistically and directly measure the spatial separation and can quickly collect information. And also we get a point cloud or mass export. It is a common format to sharing across multiple platform, and can create a 3D model, and also we can gain the infrastructure condition model to use as an input in the next stage to form a budgeting infrastructure model. This is about assessment of road damage condition. If we use a local slider, the advantages is about cost efficient, time efficiency, accessibility, usability, comfortable handling, ease of implementation, data processing, and easy of deployment. About the conclusion, about Apple LiDAR, we used to say low-cost LiDAR can produce 3D visualization and volume of pothole on damaged road. This is the second one, the utilization of the spot scan approach that can more proximate to initial volume average accuracy of 1.25%. This is better than a study conducted by Yu Yao in 2023. Meanwhile, if the scanning process is through the continuous scan method, it gives give a reasonable significant error with 11.82%. This accuracy obtained in the study is aligned with the research by Ubaidillah 2023 about difference in volume about 10% of the validation data. So the smartphone-based LiDAR system for assessment pavement condition can generate 3D model that will replace the device used from previous model as an effective way to collecting and obtaining more detailed data, including the volume of pothole. This is and then we can support with damage road type classified based on YOLO. We only look one method. Total damage area by type and roughness level generate based on model analysis result. Thank you for kind attention. Go back to Mrs. Endang. Thank you.
Thank you, Bu Sonia. We still have 10 minutes time. Is there any questions from the audience? Pak Arifin?
Yes, thank you,
Monggo.
Madam Moderator. I just would like to know the measurement scheme being conducted by the researcher, by the author, in order to get the data for analysis. She mentioned about LiDAR. I'm null in the in such knowledge, so please explain what LiDAR is and what and how the method can be done and what sort of data can be obtained from such kind of measurement and so on and so forth. And secondly, if the method is true to be more efficient in predicting the volume of the road, which is in damage or something like that. I'm just wondering if this method using the LiDAR data can be adopted in the future in view of the importance of economizing the operations and maintenance of the road, something like that. What do you think about your method to be adopted? Thank you.
Yeah. Can I respond?
Yeah, sure.
Yeah, thank you for the question. Actually, I'm from civil engineering, so I do not have more. Actually, I right now or in this field experiment, I help I have help with Mr. Nur Cahyadi, I think, with another student in postgraduate or in geometric engineering. So because actually in my research, in my dissertation research is about budgeting cost model, because I'm in civil engineering in management construction management. So if I want to make an accuracy for a budgeting cost model for a conceptual model for budgeting, so I have to gain more accuracy from the data that the previously it is gain process with manual observation, which is in manual observation it can in percentage of condition of data, condition of root of condition of data, so it can practically in very route of data that label that can be used for budgeting model. So if you ask for about LiDAR, the where I use LiDAR is this is maybe I don't have maybe Mr. Endang can help me to answer the question. I think I focus on low cost LiDAR. LiDAR is a very expensive or very high cost for measurement. So I use a smartphone, Apple with LiDAR. It is gonna from 2022 from Apple LiDAR is iPhone 13 Pro Max and also iPad Pro 2022. So I focus in low cost measurement data analysis that is more efficiently in time and in cost, but is not more significant because I compare it with the manual observation that it can be already be done in previous model. So in this study, in this case, I make study about budgeting cost model that it can be more accurate with data, with the data from low cost LiDAR and low cost GNSS. Maybe that's all I can ask. I can answer the question, Mr. Arifin.
Sorry, Madam. In this case, if you are to use your method, which seems to be appropriate way in economizing the budget of the road operation in this case, are you going to use some kind of sample observations over, well, maybe some percentage of the total road that you are going to work with, or are you going to measure all the way from A to Z, from for the whole works that you are going to work out? In this case, are you going to use a sample method or something like that?
Oh, I see. Yeah. About this, I actually have a more method with YOLO. So YOLO is we scanning by video. So we can first of all, we can scan all of the data of a road. We can scan video, scan it with video with camera. So the video is a post processing. We can see right just where it placed of a damage, and can calculate about number of damage and position of damage. So we scan all of the data by video, by taken video. So if we meet or we see the data about the pothole, this is a very big, very hard damage for road condition. Then we can get a spot scan analysis that is more for the only for the road that station that that have a pothole damage. So we can scanning all of the road damage in video. We can conduct a biolo method like I have a present about iRoad. I have only I have with a student in electro. We already have a software called iRoad that we can make a decision about where pothole or another damage classification it is placed or location of the damage. So if is there any prevention or rehabilitation in the next step, so we can make a LiDAR, low-cost LiDAR and low-cost GNSS for measurement the volume. I think this.
Okay, very good explanation. Thank you, Madam.
Thank you.
One short suggestions from me. It's better if you prepare some images or where you can explain what's the LiDAR and why on the LiDAR system that you are researching, you use a certain tools or whatever. That's maybe I assume that Pak Arifin asked you that questions because on your slides you have text in text, but not using the figure, but usually using images and what's the system that you built and what points of the system that you research, and that might more clear for the audience, probably that more give idea to Pak Arifin and any other audiences in the room. And just a small suggestion from me. But anyway,
I think I have that information, but I'm in another slide or in another. Maybe
since we don't have any do we have a speaker for presenter? No, not yet. I can give you like a minute or two for showing the picture if you have one.
Yeah, wait a second.
Maybe we'll help Pak Arifin, Pak Arifin.
Okay.
In having the figure of your research.
With my pleasure, my wait for so I'm so sorry. This is in Indonesia.
Oh, that's okay. That's
Sorry.
okay.
Okay.
It's okay.
Okay.
Just show the figure and explain it in English. That will be very useful. Can you do that?
I've tried.
Okay.
Okay.
Just use the figure and then you explain it in English.
I'm a geometric engineering. It is from LiDAR. The first maybe with the UIV, the same kind of method with UIV. It is a LiDAR is technology. We can get autonomous car, robotic, and about the scanning laser data by laser object. That is is we can get a receptor. We make a distance from the utilization about smartphone, and also we can make a light kecepatan cahaya, light inilah.
Velocity.
Yeah, sorry. This is maybe in LiDAR we get a higher accuracy. This is not more than in my focus in my focus or budgeting cost model. It is not I don't need to gain more or higher accuracy, but I focus on low cost process and faster process to conduct the data for the acquisition, and the accuracy is more accurate with the compare with the manual observation. And maybe this is another LiDAR data or LiDAR research about the survey. So I have a previous survey that is more connect about the LiDAR and Arduino to make kekasaran IEEE International Roughness Index for the road maintenance. And then from IEEE, in a further student study, we can make a LiDAR, low-cost LiDAR for laser scanner for roughness index. Maybe the next step, if we can get more deeper research, we can get laser scanning data about the collection of the data. There is so I think many point of previous research that can collect by LiDAR point clouds. So I have the different of novelty of my research is about the use of LiDAR is in smartphone. Maybe that's all I have, I think.
So you are going to use a smartphone and to make a scanning across the whole route, something like that, or what?
Okay.
Because it seems that you are also implementing in the later measurement using airplane, right?
I don't use airplane.
No, the one being presented.
Oh.
And the photo, in the photo.
Oh, yeah, it's another research about it.
Oh, okay.
I think I have one. Wait a second. One video about my research. It is so we make a first one is low cost GNSS for make a DCP. So we focus on the pothole that scanning position. So we can get the mark. It is for accuracy. And then the process of scanning, it is use iPad Pro. It's a spot scan method. Spot scan, and the second one is use continuous scan. So walking through the pothole.
Do you mind if Pak Agustan asks you a question?
Yeah.
Okay, silakan Pak Agustan. Please, Pak Agustan.
Okay, thank you very much for the presentation, Bu Yusronia. So this is very interesting topics, yeah, because this is like fall into the close range remote sensing actually. So we're very interested about the coverage. So you utilize the smartphone based, yeah. So smartphone based means the altitude is maybe the as height of the human. So it means only maximum 2 meters, for example. So the spatial coverage of the one swath of the iPhone is how many meters square, and also about the video, I think it's quite strange, yeah, because the antenna height that you use is lower than the head of the human, so the operator. So I think if the geodetic people see that kind of the technique measurement, I think it's become a problem for you. So antenna should be higher than the head, the operator's head, yeah. So
Okay.
this is just a comment. So about the coverage, I would like to know. Thank you.
Okay. Thank you. It is actually the position of scanning method is maybe another suggestion in why cannot it make a drone to take a, jadi pakai drone, we make a drone for scanning. So the smartphone is placed, maybe iPhone, maybe like hand handled. It's placed by drone or the coverage area. From this situation, we make a spot scan. So with the width in not more than 5 meter, I think is enough for the one way off road. It is enough for the collection data. And how the length is, I don't know. I'm not measure about that. Thank you for the suggestion, Mr. Amin.
Pak Agustan?
Pak
It's okay?
Agustan.
Okay. Okay, thank you very much. We ran off time a few minutes, but still we don't have any presenter for the fourth one. Okay, then your presentation will conclude this session. Thank you very much, Ibu Yusronia. Thank you, Pak Arifin Nugroho. Thank you everyone for attending this session until the end. No, I conclude this session with Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.